All right, everybody. We are in the home stretch. We only have 2 more talks left, and then we get reception. So I'll give everybody another couple of seconds to take their seats. I can talk about how I know Dan Vanderkam. I asked him to come present here because I think of Timeseries data, I kind of think of it, I break it out into 3 different areas. One's infrastructure, one is analysis of the data and prediction and monitoring of it, and the last is, I think, visualization, presenting it to the user in a way that's interesting, that gives them insight. So Dan is the creator of Dygraphs, which is a charting library that we use in chronographs, so we're obviously big fans. And I met Dan, I think it was earlier this year. He agreed to meet me for coffee in New York because he is also in New York. He's at Sidewalk Labs. So without further ado, Dan.
Thanks, Paul. Well, it's nice to go after Emily so that I know I'm not the only front-end person at this conference. So let's go over here. All right. So today I'm going to talk about Dygraphs, which is a charting library that I created, and like Paul said, it's used in Chronograph. So a little bit about myself. So as Paul said, I'm at Sidewalk Labs. Formerly, I was at Google, which is actually where Dygraphs was initially developed. I've always kind of enjoyed visual things, and I like math, so data viz is kind of a natural fit. And I've done a lot of side projects over the years, including Dygraphs, so I'm going to talk a little bit about sort of the nature of side projects in this talk as well. I did visual things at Google, visualizations at Google as well, so if you've ever searched for something like life expectancy or like a stock ticker or even like when the sun sets, those were all features that I worked on. So in this talk, we'll talk a little bit about what Dygraphs is, what it can do. I'll go through a bit of a tutorial about how to use it. I'll talk a little bit about why you might choose to use Dygraphs or not use Dygraphs. There are a lot of charting libraries out there. I'll talk a little bit about the history of the project. It's been around a surprisingly long time, about 10 years, which is quite a while in JavaScript. And I'll talk about some of the lessons that I've learned from maintaining an open source project for that long. And finally, I'll talk a little bit about what the future holds for Dygraphs. So since Dygraphs is a visualization, I think it's better to just see what it does. So let's look at some examples. So here is the tutorial page. So what you have on the left is all the code you need to make a digraph appear. So we construct the digraph, we pass in a div, and we pass in some CSV data. And voila, you get an interactive chart. So you can mouse over each point, you can see what its value is. So I think the interesting thing here is that the amount of time it takes for you to go from nothing to an interactive chart is actually quite low. You can plot more complicated data. So in this case, I'm pointing at a CSV file, and it has 2 data series in it. So we can mouse over and see, I think these are daily high and low temperatures. You can also zoom in, and by clicking and dragging. People often get confused and aren't sure how to zoom out, so you double click and it zooms out. When you're zoomed in, you can also hold down Shift and pan around. And you can also do a vertical zoom, and then the pan becomes 2-dimensional. So you can really explore your data interactively using the chart. It also includes a few facilities for doing data analysis. So in this case, I've added some options. So here I'm calculating a 7-day trailing average, and I'm showing this roller widget, which appears down here. So you can see that this chart looks a little bit smoother than the previous one. It's the same data, but it's a 7-day average. So you can start to see some of the longer-term trends. If I change it down to 1, the data gets noisy again. If I change it up to 30, then you start to see longer-term trends in the data. And as before, you can zoom in and out at will. Dygraphs includes support for confidence intervals. So if you have some way of quantifying the uncertainty in your data, Dygraphs can show that to you. So in this case, our data is sampled from 2 normal distributions. So you can see it a little bit more clearly if I zoom in. Each series has a center value and a high and a low point. Those are in this case, it's probably represented by multiple columns in the CSV file, one for the value, one for the standard deviation. What's nice is that the rolling averages understand this. So if we just go look at the raw data, it's extremely noisy. It's hard to tell what's going on. If we increase the rolling average, you can start to see, you can start to understand it a little bit better. If we go all the way out to 300, the error bars get smaller, and you can see that these are probably centered around 80 and 100. Dygraphs assumes that the errors are normally distributed so that you can average them together that way. If you have n times the data, the errors should go down by root n. Another interesting feature that sort of came out of the original use case for Dygraphs when I first built it is it's very good at charting fractions. So if you want to look at the ratio of some things that change over time, so here we're looking at the batting average for Ichiro Suzuki and the Seattle Mariners. So this is a little bit of a dated example, but I think I kind of like it. So sometimes if you're charting a fraction and you want to do averages with a fraction, if you have 100 data points one day and 10 data points the next day, you don't want to just take a 50-50 average of those. You actually want to separately add the numerators and the denominators. You want to give more weight to the day that has 100 data points than one. And so you can actually chart fractions with Dygraphs, and it will calculate confidence intervals for you and handle the rolling averages. So this is an entire baseball season. So the raw data, kind of hard to tell what's going on. But if we go out to, say, a 30-day average, this will be a 30-day trailing batting average for the team and for the player. So this is kind of crazy that over a period of 30 games at the end of the season, he was actually batting over 500. And then if you just go all the way out, by the end, this is actually his whole batting average for the season. So he batted 372, which is kind of incredible. If you zoom in here, you can see that the confidence interval actually includes 400, so he might have just gotten unlucky. He might have actually batted 400 that year. So if you have that sort of data, Dygraphs can help. You can also chart annotations. So this is the stock market. I think it goes up to 2009, would have been a good time to invest. So here I've annotated some of the stock market crashes, so 1929, 1987. And you can toggle some of the series, so maybe we want to get rid of the nominal and just look at the real, adjusted for inflation. You can zoom in, and here we start to see that actually it's not just a single value, it's charting confidence interval, or in this case, it's the monthly low and high, so you can set those specifically. So let's go back to the presentation, look at a few more demos. So I used to live in San Francisco, now I live in New York, so comparisons between New York and San Francisco, always very relevant to me. So here, this top chart, we're looking at daily temperatures in the two over the course of about 3 years. And in this case, the rolling averages can also help quite a bit. So when you go out to 14 days, you can really start to see seasonal trends. One thing I think is interesting here is if you look carefully, you notice that for a few days in 2007, the San Francisco series drops out. So we can zoom in on that. We can inspect that, maybe drop down to the original data. And you can see that we lost that weather station from, it looks like October 9th through October 31st. So I think this is one of the really helpful things that visualizations can do is you sometimes get the sense that you're actually seeing your data for the first time and understanding what some of the quirks in it are. You can, there's also this range selector feature, so you can see an overview of the chart and use it to pan around and zoom around. Google Finance has a similar feature. You can synchronize multiple charts, so in this case, when I mouse over this one chart, it selects the corresponding point in all the other charts, and same thing if you zoom and pan, all of the charts follow around. So this is quite helpful for dashboards. Dygraphs has a pretty extensive API for doing customizations. I'll show some more examples of that later. So in this case, I've used a custom function to change how the data is rendered. So in this case, it's showing bar chart. It's still ultimately time series data. We've just chosen to render it as a bar chart. In this case, we're showing a candlestick chart, which is typically used for financial data. So each day you have 4 points, an open, a high, a low, and a close. And you show the difference between the open and the close, and you color it in red if the stock went down. You color it in green if the stock went up. So this is you can write custom plotters to see that as well. You can mix these also. this was another interesting example of customizing. You can customize the interactions. So in this case, this is Google Correlate, which is a product I worked on at Google, that you would upload time series, and we would find search queries whose activity correlated with that time series. So we wanted a way for people to quickly be able to generate time series. And so what you can do here is you can actually draw a time series. So I have no idea what's going to correlate with this. We'll find out. Springfield, Missouri. If anyone knows why Springfield, Missouri peaks in 2007, drops, and then goes up. Centimeters to inches, that's also, I don't know why that conversion was popular and then dropped and then went back up. But it was kind of an interesting use case, not something that you typically would see for a charting library, but it was cool that you could customize the interaction to that extent to actually be able to quickly be able to generate time series. Dygraphs is somewhat known for being able to chart a lot of data very quickly. So in this case, we just generated a 10,000 point time series and charted it in 57 milliseconds. So we can increase this to 100, give it another try. So it takes a little bit longer this time, but hey, we just charted 1 million points. And it's still like pretty fluid. You can interact with it. It's not very laggy. You can zoom in, you can zoom in, you can pan around. So it's pretty responsive. So if you want to plot 1 million points, go for it. Here's an example of some external usage. So I just discovered this a little while back that DuckDuckGo is a search engine that's all about sort of radical transparency and sensitivity around privacy. So they're so transparent that their traffic graph, the number of people who use the search engine, is public. You can just go check it out. And they use Dygraphs. So some of the elements of this chart will be familiar at this point. So you can interact and see the number of queries they got each day. You can mouse over these annotations and see that this is probably when they were added to Safari. We're looking at a 365-day trailing average here, but if we change it to 1, you can start to see some of the noise in the data. It kind of looks like there's a weekly trend here, like a weekend versus weekday difference. So oftentimes a 7-day moving average is helpful. So it's kind of nice that you can just do that right in the browser and see the weekly average, remove that variation. So those are a few examples of what you can do with it. So let's like go a little bit deeper into how you would create a digraph and how you would configure it. So let's get rid of the CSS. So this is JSBin. So it's similar to JSFiddle and others. Just lets you live edit JavaScript. So here I have, like you saw before, I'm creating a digraph, I'm passing in a div, I'm passing in some CSV data, and I'm passing in some options. So maybe I want this chart to be filled, so I could say fill graph true, and hey, now the chart's filled. Pretty easy, right? So actually, I've been working on a tool called Just Chart It that I think is a little bit better suited for playing around with time series data. So it's similar to JSFiddle or JSBin, but you also have this spreadsheet control down here, so you can enter data sets. So in this case, say I want to change this to 25, the chart will update. And what's fun about this is Dygraphs has some TypeScript type annotations, and the editor I'm using here is the same one that Visual Studio Code uses. So we actually get contextual autocomplete for the options. So it knows about fill graph. We can learn a little bit more about it. Should the area underneath the graph be filled? Apparently this is not compatible with error bars. That makes sense. So we can set it to true and run it again. So that's helpful for remembering what all the options are called. You can do things like add a title, like my chart. It'll add a title. You can add axis labels, value. And it'll show up rotated here. Figuring out how to get that to work in every browser was pretty fun. You can set per axis options. So like, let's say we wanted to change something about the y-axis, like maybe grid lines, the grid line color. So the type definitions understand this context that we only want axis-specific options now. So maybe we want to set grid line color here to like hot pink. We want to set the grid line width to maybe 3. And we want to set a pattern to like some sort of dashed line, so maybe 20 and 10. So I don't know why you would want to do this, but if that's what you want your chart to look like, you can do it. You can also set per series options. So in this case, our series are called A and B, so we'll address them by name. So maybe we want to make this series orange. So now the series is orange. There's also a notion of which series is highlighted. So you can set highlight series options. So let's say we want to make the highlighted series have a thicker stroke. So let's say 5. And we want it to have a pattern. So like, I don't know, 20, 20. So now, when I mouse over the chart, if I'm closer, my mouse is closer to the one series, it gets highlighted. If it's closer to the other series, it will get highlighted. So there's quite a bit of ways that you can customize Dygraphs. So this is just a taste of some of those. Those options were all sort of simple ones that had string or Boolean or number values. There are also some options that you can pass functions into. So let's make this a little smaller to fit on the screen. There we go. So in this case, I've written a callback that is called right before the chart is drawn, before the lines are drawn on it, and you can use this to mark up the chart however you want. So in this case, I've used the Dygraphs API to convert from data coordinates to canvas coordinates, and so I know where the left edge and the right edge of this sort of unusual region are, and I fill in that area with this particular stroke. And the nice thing about that is, as you zoom in, the coordinate transformations remain accurate, and the underlay callback keeps getting called, so this region remains highlighted, whatever I do. I can just change these variables, and it'll update, so now it's a slightly wider region. So that gives you quite a bit of flexibility. There are a lot of callbacks like this that take functions as arguments. If that's still not enough customization for you, there's also, Dygraphs is implemented with a plugin architecture. So actually a lot of the library itself is implemented via these plugins. Things like the axes are implemented as plugins. So the way these work is you register event handlers. So this one gets called when the chart draws, right before the chart draws. And then it creates a button. And when you click the button, it resets the zoom. So this sort of addresses that criticism that it's hard to know how to zoom out. So here's what that looks like. So normally, nothing happens. Then I zoom in, and there's magically this reset zoom button that goes away when I'm not mousing over the chart. And then I reset, and it's gone. So if that's a feature that you really wanted, you could add it via that plugin. So that's sort of a tour of how Dygraphs works and what you can do with it. So there are, like I said, there are a lot of charting libraries out there. So why might you choose to use Dygraphs? I think one of the main reasons, and I think this is probably one of the reasons Chronograph is using it, is that it's open source. It's MIT licensed. So if open source is something that's important to you, Dygraphs is a pretty reasonable choice. As we talked about, it's pretty easy to go from absolutely nothing to an interactive chart that lets you explore your data. If you just want to see your data and start interacting with it, Dygraphs will get you there quite quickly. It supports showing lots of data. We just generated a chart with 1 million points and interacted with it, and it was pretty seamless. So if you're charting large data sets, Dygraphs is a pretty good option. And finally, it's quite flexible. There's many APIs for customizing it, for writing these callbacks, and also for adding plugins if you want to do something a little bit more custom. So just quickly looking at some of the other charting libraries and how I see them differing from Dygraphs. So D3 is a pretty wildly popular JavaScript charting library. But it's also a much more general tool. You can generate a lot of visualizations that are not time series visualizations with D3. And I think as a result of that, the time it takes for you to get from nothing to a chart is a little bit greater. I think one of the manifestations of this is that a lot of times the way people use D3 is they find some example that looks a little bit like what they want, and then they copy paste it and tweak it, which I don't know how you guys feel. I personally don't think that's a great programming model. And also, D3 is all about binding data to DOM elements, and that doesn't necessarily work very well if you want to use a canvas. So I'm going to talk a little bit more about what that is. So canvas and SVG, these are two different ways of rendering graphics in the browser. So SVG is kind of like XML for drawing. So in this case, you can see that we've defined an SVG tag. It has a width and height of 200. And inside of it, there are these two rectangle tags, which have coordinates, they have IDs, and you can style them with CSS. which is pretty nice. You can also use the DOM APIs, like getElementById, to manipulate them. So it fits pretty well with the way that we're used to thinking about the DOM and JavaScript. Canvas is nothing like that. Canvas is completely opaque to the DOM and to CSS. You can't really style a canvas with CSS. It's entirely imperative. So rather than adding a rectangle tag, which you could modify later, you get a reference to the canvas, you get its drawing context, you set its fill style, and then you draw some rectangles, and it's just a bitmap image. If you want to change something, you need to redraw the whole canvas, which sounds like it would be slow, but the DOM is a little bit slow itself, and in practice, redrawing a canvas from scratch often winds up being a lot faster than modifying an SVG DOM tree. So in practice, something that's happened to me many times is I've started building a visualization using SVG, and then I've had to switch it over to Canvas for performance reasons later. So I think that's actually a strength of Dygraphs, is that it's using Canvas from the start. So just looking at some other libraries, HighCharts is extremely popular as well. It's a great library. It supports lots of types of charts that Dygraphs doesn't, like pie charts. So I think the main reasons you would choose to use Dygraphs instead of HighCharts are if you care about the open source and if you want something that's Canvas-based. Chart.js is a newer tool. It's also extremely popular, supports a lot of chart types. I think the main difference I see with Dygraphs is that it's a little bit more geared towards Timeseries and has a little bit more interactivity out of the box. But these are all great libraries, and you should choose what works best for you. So just a little bit about the history of the project. So I first started working on this in 2006, which is a pretty shockingly long time ago. I needed to make a dashboard for my first team at Google. I've sort of since learned that if a new person joins a team and you're maybe not quite sure what to make of them, you can ask them to make a dashboard, and what's the worst that's going to happen? But I think I felt a little bit underused doing that, and so I really decided to go overboard on this, and I created, instead of just creating a dashboard, I made a whole interactive charting library, which was sort of novel in 2006. This was a long time ago in JavaScript years, right? This was back when everyone was using IE6, and Node.js wasn't really a thing, NPM wasn't a thing. Canvas itself was pretty new. But then a few years later, I changed teams at Google, and my second team actually got a lot of value out of Dygraphs as well. So that made me think that maybe it was useful for the broader public, so I decided to open source it. So that's when the open source project started. I think we got some early coverage on Hacker News, which started to make people a little bit aware of it. And it's gone through a few releases since then, and it's been adopted in a couple of products. It's used for a lot of monitoring tools internally at Google, which I think is one of the reasons it's not too surprising to me that Chronograph uses it. It's very well suited for dashboards and monitoring. It's also used in RStudio. You can create, if you want to create an interactive time series chart in RStudio, you probably use a Dygraph. And now it's used in Chronograph. So definitely learned some lessons from maintaining an open source project for that long a period of time. So one of the main ones is that if you're gonna start a project, you should really try to build a community around it and try to get people involved as early as possible. If it becomes kind of known as your project, that makes it a lot harder to get other people to take ownership of it later on. So I didn't really expect that Dygraphs was something I would be maintaining 10 years later when I first created it, but that can happen, and definitely trying to get other people involved early on is important. Another interesting thing I've realized is that it's mostly been a side project for the last 10 years, and so the pattern in which I work on it is it tends to be in spurts. So I'll get excited about adding something, and I'll work on it for a week, and then inevitably something else will come up with work or something else, and I'll lose momentum on it. And so I think recognizing that that's going to be the work pattern sort of leads to some interesting realizations. So one of them is that you really need to scope the work that you're going to do to be things that you can sort of start and complete while your attention is on it, because if you don't do that, it's potentially going to drag on for an unreasonable amount of time. It also leads to a lot of the pattern of writing some code and then coming back and looking at it a year or 2 years or 5 years later, which I think is actually probably one of the best ways to become a better developer or a better coder is by reading your own code that you've written years ago. you can't, if the code looks terrible to you, you can't blame anyone except yourself, right? You wrote it. So it's also helpful, I think, for thinking about like when I'm writing comments in code. When you're writing, you should always have sort of a target audience that you have in mind. And so for me, when I'm writing a comment, my target audience is usually myself in like 2 years when I've need to look at this code again, and I've completely lost all context on what it does and why it does it. So it's sort of I try to imagine myself in that situation and think about like what would I need to know to quickly understand what's going on here. Also, for doing like code reviews or looking at issues that people file, if you look at a change and take enough time to understand it and make a decision about whether you want to merge it in with a few caveats or you think it's a bad idea, you really need to like write that down right there, because the other person might not come back to it for a few months. You might not come back to it for a few months, and reestablishing that context that I think this is a good idea, we should merge it, we should just make these changes. It's helpful for you in the future because you don't have to figure that out again. It's also helpful for the person who wrote the code. But sometimes embarking on big refactors is necessary. JavaScript has changed a lot in the last 10 years, and if you don't keep up, people can't use your library in the same way. So sometimes you do need to do big changes. This one's kind of interesting. So Dygraphs has a lot of options. That's both a strength and a weakness. So I checked this morning. It has 116 options. So the first few options you add, they add a lot of power to the library, and they probably make whichever user asks for that option really happy, because the library can do exactly what they want. But when you add more options, you're not just adding, when you go from 10 to 20 options, you're not just going from 10 to 20 options, you're going from 2 to the 10 possible combinations of them to 2 to the 20 possible combinations of them, right? So really, Dygraphs has 2 to the 116 possible combinations of options, and obviously no one has used every combination of those. So a lot of Dygraphs bugs that get filed are because somebody's combined 3 or 4 different options in a way that no one else had done before, and not surprisingly, it broke. So you kind of have to, there needs to be a little bit of a bias away from adding new options and to having sort of better options. So there's some tricks that we've learned over the years for doing this. So one that I'm kind of happy with is, if you're going to have 116 options, it's better to have 116 documented options than undocumented options. So there's actually the documentation is executable JavaScript, and the thing that's nice about that is, at least in the development versions of JavaScript, every time the library itself accesses an option, the library goes and checks whether it's defined in this list. And so if you add a new option, I guarantee you're going to add documentation, because otherwise the library will just throw. You have absolutely no way to avoid this. Hopefully you also add an example of how to use it, and the process that generates the website actually it cross-references the list of options in all of the demos and tries to figure out which demos use which options, so that you can be linked over to demos that exercise the option that you're interested in. But then also trying to avoid having extremely specific options and moving more towards having callbacks and plugins helps you reduce the number of options and think a little bit more coherently about APIs. So generally today, we try to push back against adding new options if it can already be done with existing options or with a plugin. Some other interesting sort of project management things. There is a Dygraphs mailing list, but I don't think it's really a source of happiness for anyone. So if you have a problem and you send a message to the mailing list, maybe someone will look at it, maybe someone won't. And generally, if I don't respond to a message on the mailing list, you're just not going to get a response. So something I started doing a few years back was I tried to reorganize the website to push people towards Stack Overflow rather than the mailing list. So if you tag a question on Stack Overflow with Dygraphs, I actually get an email about that. So I get an email about these every couple days. And if I am interested in the question and respond to it, great, everyone's happy, and Stack Overflow will do some nice SEO so other people can discover that. If I don't answer the question, oftentimes someone else will come in and answer the question, which is great for everyone. It's also nice that people don't always know whether the question they're asking or the issue they're running into is a Dygraphs issue or a general JavaScript issue. And so with a mailing list, that's kind of frustrating because I don't want to provide general JavaScript support to people. But if you ask those questions on Stack Overflow and people see that it's really a JavaScript issue, some JavaScript people will generally respond to the question. So switching the support over to Stack Overflow has been a huge win. I would encourage any project maintainer to do that. GitHub issue templates are really great. I created this dygraphs.com/fiddle link a few years ago. So that takes you to a JS fiddle that has a digraph in it that you can customize. And I basically close any bug report that doesn't have a link to one of those at this point. It's just a way to encourage people to create concise, reproducible bug reports. And I personally find those much more compelling to actually go in and fix and try to understand. So staying motivated for open source projects is sometimes challenging because with a mailing list and with Stack Overflow, generally the only time you hear from users is when they're confused, right? So if you constantly are getting messages on the mailing list about things that are confusing people, it kind of makes you feel like, oh, maybe I just created a confusing library. So with Stack Overflow, you can sort of follow what people are confused about. And NPM stats, I don't really know what those mean. I don't know what 10,000 downloads in a month means, if that just means that a lot of people are installing it on their continuous integration server, or if they're actually using it on their dev box. GitHub stars are kind of nice. Like, that is a nice sign that people are interested in the project. So if there's open source projects out there that you use and you haven't starred, just like go give people a GitHub star. It doesn't really mean anything, but it'll make them feel happy. Google Analytics for the website can maybe be a way of tracking usage, though I think that sort of has the similar property that people probably go to the website when they're confused and want to look at the documentation. So I don't really have a great answer for this of how you track usage of a client-side JavaScript library. So I'm interested in ideas that other people have. So this is another sort of hack that I discovered was screenshot testing. So I'm sure some people here have done this as well. So there are unit tests for Dygraphs, and we run those every time someone merges a PR. But when you want to do a release, generally what I would find myself doing is looking at all the demos and trying to see if they'd actually changed between the old version and the new version. And it turns out you can actually automate that. So let me just show you guys what that looks like. So make this a little bigger. So here I have a separate repo that has it brings up a server and then visits all of these URLs and takes a screenshot. It's using Phantom.js. And so in the repo, there's just a bunch of PNG files with screenshots for those that were taken at the time of the last release. So if you want to update the screenshots, you you run the Phantom.js script again. It's a separate repo, so that makes it easier to do like git bisect in the Dygraphs repo itself, so that you can do binary search to figure out exactly which commit changed a screenshot. So in this case, I reran this morning. So 2 of the PNG files changed, 2 of the screenshots changed. So if you do git diff for binary files is not that interesting. But there's this other tool which I helped build called git webdiff, which will actually understands how to do a diff between 2 images. So this is one of the demos that changed. So we can use image magic to highlight the pixels that changed. So in this case, it looks like on the second chart, some of the hours changed. And on the third chart, everything changed. And on the fourth chart, some of the hours changed. So another way you can try to get at this is by using this blink mode. So every second or so, it oscillates back and forth between the 2. So down here, we can see that these numbers changed by, it looks like about 3 hours. And down here, it looks like the whole chart shifts by about 3 hours. So my guess is that what happened here is I generated the golden images on the East Coast, and then when I reran, I generated them on the West Coast, and everything shifted by 3 hours. So there you go. If you ever think that writing a charting library is simple, this chart of a time series going across a daylight savings switch should maybe discourage you from that thought. So here's an example that was a real change. So it looks like the test that we took the screenshot of before it didn't have a range selector, after it did have a range selector. So maybe that was just some change that crept in inadvertently. So this is a really good way to look for regressions between when you're doing releases. So what's next for Dygraphs? So I think one of the big things, like I've mentioned, I'd like to broaden the ownership of it. So now that RStudio is using it, now that Chronograph is using it, I'd love to get them and get more people involved in maintaining the product and doing releases and looking at pull requests. I think sort of doubling down on some of the strengths of Dygraphs is in the cards. So there are a lot of ways that panning and zooming could be faster, and I think it could be easier to create charts where you initially show an overview that has course data, like daily data, and as you zoom in, you go back to the server and fetch like hourly or minutely or secondly data. I think that's something I'd like to support, do a better job of supporting. I think some notion of like option sets, so themes, would be helpful. So generally, you don't just use the vanilla settings of Dygraphs. You probably add like 20 options, and so there's probably some sets of options that people add regularly together to make the chart look the way they want. So I think having some first-class support for that would be helpful. I think there's also an opportunity to integrate with some of the popular frameworks out there, like React or like Angular, to sort of have a chance to rewrite some of the APIs that I'd like to get rid of. So that's, I think that might also be something that's in the future. So that's Dygraphs. Thanks. Yeah, so we have a few minutes for questions. Question over here.
Will it always be time series only, or will you make it more general purpose at some point?
I think I'd like to focus just on time series. I think if you want to create pie charts or something else like that, there are a lot of other JavaScript tools that do a good job of that. I don't want to be like the one JavaScript charting tool to rule them all. I think that's just like not going to lead to happiness. So there are other great tools if you want to make a pie chart. Any other questions? Yeah.
I guess some more feedback. We actually looked at die charts over the summer. We ended up going with eCharts, which is from Beidou. But the two things you got there, loading from the server and themes, they were the two major things that were missing for us. So that's why we didn't go with you guys.
Cool. It's good feedback to have.
But that's really good to see on the next steps.
Any other questions? Yeah.
Hey, great library. Do you support Node Canvas, rendering to Node Canvas, or any way to render on
so like server-side rendering?
Yeah.
I haven't actually tried it myself, so
yeah,
I don't know if that works.
Yeah, that might be really cool, because we're looking at possibly doing some sharing capabilities with graphs. So it might be nice for.
Yeah, I mean, I think the only server-side rendering I've seen is using something like Phantom.js that runs a headless web browser. But yeah, it's an interesting idea.
Yeah.
I mean, I think you lose all of the interactivity benefits if you do that, right?
Yeah.
So.
But it might be nice for like OG tags and for just downloading a graph and that sort of thing. So.
What kind of challenges do you foresee have you looked extensively at all into like a React integration, and if so, what kind of challenges do you foresee with your library so far?
Yeah, I think the question with a React integration is like how deep you'd like it to go. So I think doing a really shallow React integration where you just pass in all the options as props to a React digraph would be extremely easy. Like, it would take an hour to do. But I think a deeper integration where you had a separate component for like the y-axis and for the x-axis and for the legend might be more interesting, but would involve a lot more thinking about the API. So I think the challenge there is just deciding like what makes sense.
As the owner of an open source project, how do you, what's the best way for someone to do something like, let's say I want to go home and I want to start hacking on some Angular integration or whatever. So, you know, should I fork the project, or should I make something on my own and then send it back to you? Like, what's the best way to say, hey, I'm trying to help you, and not be like, hey, I'm trying to steal your stuff?
Well, please don't permanently fork the project. Yeah, so I mean, I think you should just go home and give it a try. And you know, if you come up with if you create Angular Dygraphs and publish it as a repo, I would be extremely excited about that. So yeah, I think the more usage, the better. But yeah, I mean, if you wanted to do that and ran into issues, you know, send a message to the list, or maybe ask on Stack Overflow if it's appropriate. But yeah, I think just like give it a try. I think that's going to be the most fun thing and probably the most valuable. Any other questions? All right, thank you.
All right, we have another quick break until 4:30, and then we have the last talk of the day, and after that, the reception. So, see you in a few.